Hello and good day, geometry. We're looking at CO37, looking at some more proportionality theorems. Fresh off of PO36, we learned about the three theorems. They have great wings there. The three theorems to prove that triangles are similar. And here are just some other things that can happen, particularly within triangles or parallel lines. That brings us to some more similarity situations. So the first one is the triangle proportionality theorem, or the TPT, says that a parallel line in a triangle will divide the other two sides proportionally. Okay, so I'll let you write that down. A parallel line in a triangle will divide the other two sides proportionally. Our parallel line is marked here in the triangle that we have. Segment WY is parallel to segment VZ. And what that means is that those other two sides, VX and ZX, are divided proportionally. So we've got VW here is proportional to ZY, and WX here is proportional to YX. So for our job here is to find the length of YZ, segment YZ, we can set up the proportion VW, which is 35, over ZY, or YZ, which is what we're trying to find here, is equal to WX, which is 44, over YX, which is 36. Of course, that's not the only proportion we could set up. We could also go straight across. We could say 35 is to 44, as X is to 36, right? And the reason why both of those proportions work is because using cross products to solve this, which is what we're going to be doing here, the position of our numbers, it's going to be the same thing. And in each of these, we'll be multiplying 35 by 36 and then dividing by 44 in order to solve for X. So 35 times 36, quick maths, is 1260, and divide that by 44, and we get a value of 28.63. That didn't work out very evenly. Okay. Where can I write that? 28.63. And how we can check this is we can, take a look at these fractions here. 35 divided by 28.63, get the decimal value of that is 1.22, etc. And 44 divided by 36 is the almost the same nasty decimal, because we rounded 28.63. It's not perfect, but there we have it. Okay. Theorem 6.5, the converse of the triangle proportionality theorem. We've talked about the converse of things before. This one says that if two sides of a triangle are divided proportionally, then the segment is parallel to the third side. And the segment that we're talking about is the one that's inside the triangle, that PS there. And then the third side, the one that's not marked with anything, is that QR. So we're able to determine if PS is parallel to QR if the way the triangle is sectioned off, if those sections are proportional. So in this case, we are testing NP with NS and PQ with SR. So setting these proportions up, we're saying is 90 over 72, is that equal to 50 over 40? Okay. Of course, we could also go horizontally too. We can say, is 90 to 50 equal to 72 to 40? And the reason why both of these proportions work is because using cross products, which is what we're going to use here, we're multiplying the same numbers together. So 90 times 40 is 3,600. 50 times 72 is also 3,600. And because 3,600 is equal to 3,600, we can say, yes, PS and QR are parallel because that triangle is sectioned off proportionally. Okay? I asked for questions, but you can't ask them anyway if you have them right now. So if you do, then shoot me an email or come on in for some help. But let's look at what comes next. Theorem 6.6. Okay? Theorem 6.6 says that if three parallel lines, okay, and let's identify our parallel lines here. We are saying that FE and G, there's no point there, but these three horizontal lines are all parallel. Okay? So if three parallel lines intersect two transversals, and remember, transversal is just something that connects two parallel lines. So our transversals here, I'll highlight them in red. We have FH, which goes through all three parallel lines, and EC, which goes through all parallel lines. So if three parallel lines intersect two transversals, then the transversals are divided proportionally. Okay. If three parallel lines intersect two transversals, then the transversals are divided proportionally. So, which means that these sections here, FG and ED, are proportional. Okay, as are, doing green, GH and DC. Okay, it's not the parallel lines that are sectioned off proportionally. So these three here in the middle, I just put tick marks through, they are not proportional, but the transversals are. So we have blue with blue and green. And the question is here, what is the distance between Main Street and South Main Street? Okay, what is the difference between, or the distance between Main Street and South Main Street? So basically, we're looking for FH. Okay, that segment FH gives us the distance from Main Street to South Main Street. And even though EC also goes from Main Street to South Main, since it's diagonal, it's going to be a longer distance than FH. So we're going to go with the shorter one here. And so what we can set up here, basically, we have a value for FG, we have a value for ED, we have a value for DC. We're looking for GH. We need that missing piece to answer this question. So a couple of different things we can set up here. We can go 120 is to 150 as X is to 300. Or we could go 120 is to X as 150 is to 300. Okay. Either way is fine because using cross products here, we see that what we're multiplying is in the same spot. The way that this is set up, though, I actually really like this 150 over 300 here because 150 over 300 is equivalent to 1/2, isn't it? So if we rewrite this proportion, 120 over X equals 1 over 2, we actually don't really have to use cross products here. Okay, because our numerator is going to be half of the denominator, and so X has to equal 240. To say that 120 over 240 is equal to 1 over 2. It's equal to 1/2. So this being 240, GH there, we can erase the X because we solve for it, and also erase half of everything else I drew there. Put that back in there. And if our question is, what is the distance between Main Street and South Main Street? Well, FG is 120. GH we calculated to be 240. Therefore, 360 is the answer, okay, which is the length of FH. So this is another example. We've seen this before to where we had to solve for X, solve for GH, but 240 wasn't our answer, okay? It was just a means to get to a larger question, which was what is the length from, or the distance from Main Street to South Main Street, okay? Theorem 6.7 deals with an angle bisector there, right? We see an angle bisector, segment PR, that red segment, is an angle bisector within that triangle. And what Theorem 6.7 says, an angle bisector in a triangle will divide the opposite side into sections proportional to the other two sides of the triangle. Okay, an angle bisector in a triangle will divide the opposite side into sections proportional to the other two sides of the triangle. Yikes, that's kind of wordy, isn't it? Okay, so let's break it down. It says an angle bisector in a triangle will divide the opposite side into sections. So we have sections here from the opposite side. We have QR, and we have, I can't use black, it's already black, RS there. Okay, so that angle bisector divided that opposite side into two sections. Those two sections are proportional with the other two sides of the triangle. So QR is proportional with QP, and RS is proportional with PS. So if our job is to find the length of RS, okay, knowing that that whole side is 15, we need to be careful how we set this up, right? Because what's the value of QR here, that section, QR, if RS is X and the whole thing is 15? Well, kind of using the segment addition postulate, we can say that this is going to be 15 minus X. Okay, 15 minus X. The whole thing is 15. We subtract RS from that. What we're left with is going to be the value of QR. Okay, so we have 7, setting our proportion here, 7 over 15 minus X is equal to 13 over X. Right? 7 over 15 minus X equals 13 over X. That's the proportion we can set up here. And so using cross products to solve this, we have 7 times X is 7X. And that equals, and remember here, we need these parentheses because we are multiplying 13 by that whole thing, that whole expression, not just the 15, not just the X, but the whole thing. Doing some simplifying, we've got 7X equals 195 minus 13X. We distribute there. Move that 13X over to the other side. That gives us 20X equals 195. And I must have been in a mood when I put this together for a lot of decimal answers here. The class must have been on my nerves or something. I don't know. And we get a value of X equals 9.75. Okay, but again, that's not the question here, right? The question is, what is the length of RS? And if X is 9.75, oh, that does end up being the question. Never mind. RS is our value for X here. The length of RS is going to be 9.75. Okay, and since we've got a decimal answer, just want to make sure they don't come along too often. Let's check this. What's the length of QR? 15 minus 9.75 is 5.25. So QR is 5.25 here. And just checking our decimal values, if I take 5.25 divided by 7, I get 0.75. I was not expecting that, to be honest with you. And then if I take 9.75, which is the length of RS, and divide that by 13, I hopefully get 0.75. Oh, I do. Woo! I was about to be really embarrassed. I was afraid of that. So it does check out, and these 4 theorems here are all different things, focusing on triangles and parallel lines here, different ways to divide things proportionally. Okay. All right. Your homework for Tuesday, our next live class day, I would like you to look at page 400. And on that page, let's do 3 through 11. 3 through 11 on page 400. I feel like anything else today? Oh, any review questions might have you? Oh, number 24. That's a good one. I've done that one before. So 3 through 11, number 24, and then that will be it. Okay. So page 400, 3 through 11, and 24 homework due on Tuesday. We have one objective left. We'll cover that next week on our live lesson Tuesday or Wednesday, and then we'll talk more about when the test and everything that's going to be after that. So until then, that's how you math. Don't forget to like and subscribe, and have a great day. Bye.